Let's finish the second part of the 7.3 Day 2 lesson, Solving Quadratics in Radian Form. Be sure to have a calculator and then go to the bottom of this page. It says to solve for values of theta between 0 and 2 pi. That's going to indicate that we are in radian mode. Make sure to convert that on your calculator. Also recognize that it says to round any approximations to the nearest hundredth. So radians always go 2 places past the decimal. As we look at these 3 examples, we're not adding any more on, but we are going to complete all 3 of these. So make sure that you guide your space accordingly. In this first example, we have secant squared theta minus 1 equals 0. Looking up above, this would be like the situation for step 1. If you have a quadratic term, but you're missing that linear term. So the first thing we want to do is isolate that quadratic or that squared term. And we'll do that simply by adding 1 to the other side. That gives us secant squared theta equals 1. So when we take the square root, that cancels out the quadratic and just gives us secant theta. And remember, we have to consider that plus or minus rule when we take the square root of the other side. Now, the nice thing about this one is the square root of 1 equals 1. Also notice that we have a reciprocal function here. So the next step before we take the inverse of each side is to take the reciprocal. We do 1 over secant theta, and then we'll do plus or minus 1 over 1. Now, 1 over secant theta is going to be the reciprocal for cosine theta. And the nice thing about the other side is that 1 divided by 1 just equals plus or minus 1. But this is unit circle friendly. So as we think about solving for theta, we have to split this apart and set cosine equal to positive 1 and cosine equal to negative 1. Both of those rules will apply. Now, negative 1. There we go. So we're on the unit circle. Does cosine equal positive 1? Well, that would be at 0 radians. And where does cosine equal negative 1? That would be at pi. So there are only 2 answers, one for positive 1 and one for negative 1. Notice we're not using 2 pi as a solution because 2 pi is beyond our radian values. Remember, it says less than 2 pi right here, so we can't include it as an option. Therefore, we use 0. Notice our second example, letter F. 14 cosine squared theta plus cosine theta minus 3 equals 0. In this example, we have our quadratic and our linear term. So this is going to be like option 2 up above. We have to set it equal to 0 and factor. Notice it's already set equal to 0 for us, so we're ready for that factor step. Now, we have to do a times c split to get the bx term this time because of that 14. If I take 14 times negative 3, we get negative 42. That's a 4 right there. There we go. Now, lots of numbers go into 42. We can do 1 and 42. We can do 2 and 21. We can do 3 and 14. 4 doesn't. 5 doesn't. 6 does. We could do 6 and 7. And I believe that's it for our pairs. Now, we have to figure out which pair would multiply to be negative 42 and then add to get a coefficient of 1 in the middle. If we keep 6 negative and 7 positive, that will do the trick. So what we're going to do is split up that bx term into negative 6 cosine theta. Whoops, hang on. Negative 6 cosine theta. Here we go. Plus 7 cosine theta. And then we need to drop down the first term out in front. So 14 cosine squared theta. And that last term at the end, minus 3. So remember this process, now we have to put a parenthesis around the first 2 and the second 2. What could we factor out of 14 cosine squared and 6 cosine? We could take out a 2 and a cosine theta. When we do that, we would get 7 cosine theta left over for the first one, minus, if we take 2 cosine theta out of 6 cosine theta, we would get 3. Now here's where we have to be careful. Some of us got stuck on this in the first half of chapter 7. If nothing comes out of this parenthesis, no common factor, we need a placeholder of a 1. That won't change the inside, but it'll help us with our factor process. And now our two parentheses match. That indicates one parenthesis for our factored form. But here's where that 1 is essential. Take the two parts on the outside to create that second parenthesis. And that would be 2 cosine theta plus 1. And then this all equals 0. Now that it's factored, we have to split up the parentheses and just kind of solve them separately. We'll take that first one, 7 cosine theta minus 3 equals 0. And now that the quadratic is gone, we just solve using our primary rules like we did in day 1. I'm just going to move 3 over and then divide by 7, like so. And we get cosine theta equals 3/7. This is not unit circle friendly, so let's go ahead and grab our calculators. We'll take cosine inverse of 3/7. Now remember, we're in radian mode, so make sure to have your calculator in that mode before you plug this in. And then we have to think about how to get our rules using those primary rules from day 1. When we take the inverse to the nearest hundredth, I get approximately 1.13. That's my first answer for cosine. The second answer is 2 pi minus theta, or 6.28. So we just subtract. Our second option then is 5.15. So these are the first two solutions that we get, and then we have to solve that second parenthesis. If we have 2 cosine theta minus or plus 1 equals 0, get cosine theta by itself. We'll divide by 2. And now I have cosine theta equals negative 1/2. Make sure that negative is clear right there. We just want to make sure there's no question. There we go. Now this is unit circle friendly. Negative 1/2 is one of our angle measures that is on the unit circle. Now in radian form though, be careful. We're not going to do degrees for this one. If we look at negative 1/2, that's on the left side of the unit circle, that would be at 2 pi over 3 and 4 pi over 3. So there are 4 solutions for this quadratic equation. Our last example gets kind of tricky, so I wanted to make sure to put one like this on here for you as reference. We have 2 sine squared theta on one side equals sine theta on the other. So we have to be careful. If there's a quadratic term and a linear term, we have to set this equal to 0 and factor. We can't just cross off one of the cosines. I know that seems like it'd be faster, and technically it would be faster. It just unfortunately wouldn't be correct. So let's go ahead and move that sine theta over. And now these aren't like terms, so here's another thing to be careful about. If you have a squared term and a linear term, we can't add and subtract them. We just have to leave it as one big subtraction problem. That would give us 2 sine squared theta minus sine theta equals 0. And now we have to factor. We've got this first term and the second term. Now, what do they both have in common? They both have a sign in common. We're not going to divide it out, but we can factor it out. If I put a sine theta out in front, let's see what's left over. In that first term, if I take out a sine theta, we still have 2 sine theta. Minus, and in that second term, if I factor sine theta out of itself, we need that placeholder of 1. And just like that, it's factored. Now to go to the second step, set each part equal to 0 and take the inverse. Using our primary factor rules, notice 0 is going to be unit circle friendly. Where does sine equal 0? That's the y-coordinate. It equals 0 on the right side and the left side. So at 0 radians and at pi radians, that's when the sine value equals 0. Not too bad. Let's go ahead and solve the parenthesis. We have 2 sine theta. Wow. Let's get that to look better. 2 sine theta minus 1 equals 0. Move the 1 over. We have 2 sine theta equals 1. Divide by 2. And we have sine theta equals 1/2. Again, look at that, unit circle. So where on the unit circle does sine equal 1/2 in radian form? Well, it's going to be on the top, on the right side and the left side, at pi over 6 and at 5 pi over 6. So the solving rules are the same for degrees. We're just now looking at radian form.